Hi everyone, today we're going to dive into the OPT4048 sensor, a powerful ambient light and color sensor. We'll cover everything from its physical setup, using a light tube, to getting its data to a computer wirelessly and smoothing that data for more reliable, stable reading. The OPT4048 is great because it has a wide dynamic range and very high resolution color correctness, making it perfect for applications that require precise light measurements. This can be used in everything from display brightness control to smoke measurement. I got the breakout board soldered, and it fit right into the 3D printed part that I wanted. I noticed something coming off the board that was green, a green light. Why would you put a green light on a color sensor? The physical setup for the OPT4048 is straightforward. The breakout board is small and it is best to mount in an enclosure. An important part of our enclosure is the light tube. The OPT4048 is highly sensitive and can be affected by light from all directions. By placing a light tube over the sensor, we can collimate the light, which means we are only measuring light coming from a specific direction. This is especially useful for applications where we want to measure the light from a single source, like a transmissometer. The light tube effectively acts as a shield, focusing the light and giving us a more stable reading for baseline measurements. We began by testing a white light, a green narrowband light, a 700 nanometer light, and a 200 nanometer UV light. Now let's talk about getting the data from the sensor to our computer. We're going to use an ESP32 microcontroller and ESP-NOW. ESP-NOW is fast, low-power wireless communication protocol. It is fantastic for our use case because it allows two ESP devices to talk to each other directly without a Wi-Fi router. We can have our sensor attached to the ESP32 and a second ESP32 connected to our computer. One ESP32 acts as a sender of the data and the other acts as a receiver. The code on the sender will read the data from the OPT4048 and then use ESP-NOW to broadcast the data packet to the receiver. The receiver ESP32 which is connected to a computer via USB, will then listen for the packets and send the data to the computer over the serial port. This gives us a simple, efficient, and wireless way to get our sensor readings. Let's address a common problem: data drift. Even with the light tube, our sensor readings might have small fluctuations. These small random changes can make our data seem noisy. To combat this, we're going to use alpha smoothing. We're also known as exponential moving average. This is a simple but powerful algorithm. The basic idea is that new incident light value is a combination of the old incident light value and the new sensor reading. We use a parameter called alpha, which is a number between 0 and 1. The formula is keeping alpha around 0.5, we found worked with most light sources. When the light source gets brighter, a new max light value is selected. This prevents negative opacity values. However, if the light drifts lower and dimmer, this algorithm will follow the drift down to keep the opacity in an open and clear beam near 0. A low alpha value will still slowly adjust to long-term drifts.
Where warmth is key, a secret hero works to keep the air free. No smoke, no fumes, just clean and bright. A smokeless chimney shining with delight.